Okay, in this presentation we're going to look at planes. So this is sort of the linear algebra sort of part of the course. Okay, and what we're going to look at is planes. So what we're going to have here, what we have here, this is essentially extension of vectors. So this is our plane, the equation of our plane here. 2x minus 3y plus 4z plus 17 is equal to 0, okay? The first thing we're asked to do is simply state what is the normal here. The normal is we have three-dimensional space here, so it's three dimensions, x, y, and z essentially. And essentially the normal is those coefficients associated with x, y, and z. So the normal is 2, minus 3, and 4. Simple as that. Just pick them out from the equation there. That one there, that one there, and that one there. Okay, that's our normal. Okay, the next thing we have to do is we're going to answer a couple more questions here. The second thing is the point 2, 4, minus 2 on this plane? Okay, so is it on this plane? So is it a point on this plane? Okay, I have another similar one here afterwards. 2, 4, minus 2. Okay. So what we're going to do here is make a little space here for ourselves, is that we will just actually sub in the values into the equation there. So it is 2 times 2, and just sort of see what we get. Minus 3 times 4, plus 4 times minus 2, plus 17. And what we're going to do is evaluate that and check to see if it is 0. Now you probably could sort of do a bit of mental arithmetic there and sort of see, no, it's not. So that's 4 minus 12 minus 8 plus 17. Is that equal to 0? No, that's actually equal to 1. Okay, and that's not 0. That's what we're sort of looking at there, not 0. So the answer is no, it is not. Let's do a sort of similar one there. Okay. So the answer there, actually, just to sort of remark, is no, because the equation does not give us 0. Okay, if we got a 0 there, then we can sort of say it's a point on the plane. Just let's have a little look at a counterexample here. So what I'm going to do here is a sort of a second example, and we're just going to try out a second point. Okay, and this time the point is 3, 9, 1. Is that a point on this plane? So let's try it out again. Now, just quickly, what we'll do there is, actually, we just have it at the top of the screen there. Do something similar. 2 times 3 minus 3 times 9 plus 4 times 1 plus 17. What does that give us? Well, that gives us 6 minus 27 plus 4 plus 17. That is equal to 0. That is equal to 0. So this one is, yes, this is a point on the plane. Remember, actually should actually sort of state that. Yes, 3, 9, 1 is point on this plane. Just actually sort of specify the answer like that. Just having equal 0 as the sort of final statement of your question, you have to actually spell it out. Okay, on plane. Now, one more thing we're going to do here is a plane parallel to the one we've seen previously, parallel to question 1, okay, or whatever, parallel to this plane here, okay, parallel to this plane here. I'll just give this name here, P1, okay. So, parallel to P1, passing through, let's make up a number here, 444. Okay, 0.444. Okay, so what we're going to do here is we get our normal. Okay, essentially the gist of it is this. It is the dot product of the normal that we have previously. So what do we need actually? We have our point, okay, but we also need the normal from point P1. So the normal we've seen previously there was 2, 3, or minus 3 and 4. Okay, so we need the normal and we need a point, and that can give us the equation of the line. Okay, so essentially this plane here is going to have the same normal as P1 because they're parallel. Okay, that's the idea. So it's the same normal, just through different points. So the first sort of way we could write it is we write out our normal here, 2 minus 3, 4, and the dot product of x minus 4, y minus 4, or z minus 4. Okay, that's one way of writing the equation of the line or plane we're looking for. But what we could do here is just add them up. Or essentially, just to sort of work it out, this is 2 times x minus 4 plus, minus 3 times y minus 4 and plus 4 times z minus 4, and let that equal to 0, and we're done. Okay, so the answer would be 2x minus 8 minus 3y plus 12 plus 4z minus 16, let that equal to 0, and just sort of rearrange the coefficients. Well, we get 2x minus 3y plus 4z, minus 8, minus 16 plus 12, that gives us altogether minus 12. Okay, when we sort of add up these three terms here, this one, and this one, that gives us minus 12 altogether. So the answer for this fourth part here is that's the equation of the plane parallel to P1. Let's call this P2. Parallel to P1, passing through the point 444. Okay, you can put in the values there yourself, and you'd sort of see pretty quickly that it should give you. We'll just check that actually. We'll just make sure it works right. We'll just check that the point 444 goes through that. So what do we have? 2 times 4 minus 3 times 4 plus 4 times 4 minus 12. What does that give us? That gives us 8 minus 12 plus 16 minus 12. Yeah, that gives us 0. So that's a quick sort of rundown of working with planes through just a sort of quick introduction to planes as part of the vectors, as part of linear algebra. Equation of the plane, normals, and so on.